Okay, I'm going to read the question and then pause for a second so you can pause this video and work on it, and then I'm going to go over the answer. Okay. In polynomial interpolation, our goal is to fit a polynomial given some information about points and derivatives of the desired curve. As seen in lecture, we can solve this problem by formulating it as a system of linear equations in the coefficients of the polynomial, and then finding a solution to these equations. Okay, list all degree 2 polynomials satisfying these 3 points. Okay, so we know that the form of this polynomial will be this, since it's degree 2, and we can plug in these 3 points and get a system of linear equations. So f0 equals 1, which equals c, because if you add 0 here, these will all both cancel out, and you'll just be left with c. f1 equals a plus b plus c, and f2 will equal 4a plus 2b plus c. Okay, so if you've taken any linear algebra, then you'll know that you can just solve for a, b, and c using this system of linear equations. So I'm just going to do this by substitution. So we know from the first equation that c equals 1. So I'm going to rewrite the second. And I'm going to rewrite the third. Okay, and this is the same as a equals 1 minus b. So now we'll plug this into the third one. So we'll get 4 equals and we'll get that b is equal to 1. Okay, so now, b is equal to 0. Okay, now we'll just substitute b back into this equation here, and we'll find that a equals 1. So now we know all 3 coefficients, and therefore our final degree 2 polynomial will be t squared plus 1. Okay, on to the second part of the question. What about a degree 3 polynomial? So that will be of this form. However, we know from the previous part of this question that this polynomial will actually solve our constraints. So we know that this can actually take the form of our previous solution plus another polynomial, where the second polynomial will be a cubic one. Okay, so our second polynomial will actually be of this form. And we can just do the same thing as before, where we will plug in our points and get our equations. So we'll have d equals 0. Okay, and then we can solve the same process as before, and we will find that b equals negative 3a, c equals 2a. So what does that mean? That means our final answer will be of this form, plus f2. What is f2? Well, we'll plug in these here. So we'll get a x to the 3 plus minus 3ax squared plus 2ax, and then plus 0. Okay, and then what do we have here? Let me just simplify this a bit so we don't have, oh, you know what, these should be t's. Minus t squared plus 2t. Okay, and you'll notice here that we haven't assigned a value to a. That is because we only have 3 points. So if we want to fully define any degree 3 polynomial, we will actually need 4 points. So 1 plus the degree of the polynomial. Here, since we only have 3 points, that means our answer is actually infinitely many polynomials that will take this form. So you could plug in any value of a, and it will still satisfy the above 3 constraints.